Hey, good afternoon. I gotta turn my robot on. Just a second. Here's a little blue light. Okay, so it is still Tuesday, March 4th. I'm still Rob, that developer dad, and we are still working on my silly little let's make a pixel art editor in JavaScript experiment. The primary purpose of this shorter series of streams is to demonstrate how I, as a experienced software maker, collaborate with an AI model slash coding assistant to produce new functionality that I need for other things or what have you. And we're having a great deal of success, and I'm actually gaining a deeper understanding of and stronger confidence in working with JavaScript, because for the past 20 years, I've been pretty much exclusively .NET based languages, primarily C Sharp, and primarily in the back end, not doing a ton of work in the browser. So let's take a look at what we've got so far. There's not a ton of visual change since this morning. However, I've got some events propagating here and there. And right now, I've got an event that is being raised whenever the actual color in my palette editor, whenever the swatch actually changes and loses focus. You can see we've got palette editor view model, handle color change. It's raised that event. My event bus says it's publishing the event, palette color changed. Pixel editor says it's handling the palette color changed event for palette index 8. The new color value is this. And then, of course, it's raising a new event called state updated. And I don't have any handlers on that state updated event yet. So I can come back to the LLM, and I'm just rearranging some panels on my other screen here so I can watch the chat and keep my browser and the browser tools available to me. Okay, so let's restructure the event handling in the pixel editor class. We've done that. And in this pixel editor class, it had originally suggested that we add the code to capture these events as they come in right here in the constructor. And I said, no, because we're going to have a bunch of events that the pixel editor class needs to deal with. So let's put the actual subscription activities into a private function and then add private functions for each discrete event that the pixel editor class needs to be able to handle. And of course, this is just an anonymous function that accepts the incoming event data from the bus, like the index and the new color. I log out to the console that the pixel editor is handling this event with this data. We update the internal state on the palette with the new color information, and then we simply publish an event that we're now going to subscribe to in the color picker. So let's get into the color picker part component and subscribe to and handle the state updated event when it occurs. So I can close the palette editor view model. We're done working with that for now. Our swatch editor, it's fine. We can close out of all of these independent CSS things. Image editor view and view model, we're not ready to deal with those yet. So let's see here. And we'll hover over this, and it wants to make edits to the color picker view model. Here it goes. And we'll accept these 4 changes. So first thing it's doing is it's adding the event bus as a parameter. And that means we're probably going to need to go out to the pixel editor component and update its invocation of our color picker view model. That might actually have to happen in the image editor. I'm not sure where that component tree or where this sits on the component tree, but we'll get there. Subscribe to state updates. So here's this. It's subscribing to state updates. Let's go to the definition. Here we go. Editor events state updated. Update type equals palette. Update action equals color change. Color picker handling state update with the update data. This.palette.colors, update index, update.newColor, and then notify the view that it needs to refresh. So this.onPalette changed. Now we got to update the color picker view. And let's go ahead and do that. Now I don't think, okay, this does have a bind local events now. And what's in bind local events? I don't think it's got a method for that. Nope. Okay. So before I save the change to the color picker view, we're going to need to add a bind local events function. I'll do that now, but just leave it stubbed. So I'm going to pop down here and just do a bind local events. There's that. And we'll add some JS doc. Binds handlers for color picker elements that whose events should be scoped only to the color picker view instance. Save. Okay. Let's set up the event handlers for the individual color picker buttons now. Hey, Johnny. Find local events, add event listener. Okay, yeah. So let's do this. Let it apply its code changes. And then we've got to do some eyes on screen testing of some things once these are all connected. Oh, geez. Crypto stuff. I don't mess with crypto. I used to work for a company that does stock market and investment analysis and everything like that. And just the whole concept of cryptocurrencies and everything like that, it's weird, man. All right. So let's see what's happening in here. If I click on 3, we get that. If I click on 8, we get that. Good. We're transparent. A. Let's click on 8. And I'm going to come over here and edit this so that it's a darker color. 128. Okay. Because we haven't subscribed to the state updated yet, that doesn't change yet. But we do get this. And there's that. Optional add keyboard navigation. I wonder what that does. So I'm going to put it on 8. Oh, it's repainted finally. Yeah, keyboard navigation is silly. Prevent page scroll. This. There's that. Let's just get rid of that nonsense. And that was part of that nonsense. I'll take a look at it in a few minutes, Johnny. Okay, so we are able to select our colors. Good. All right. I removed the keyboard navigation. That seemed we don't need that. Let's add a label in the selected color. I want to see what the name of that element is. In the CP selected swatch div to display the selected colors index, just like we have in the CP color swatch elements. All right, so this updates our render method. And it's just going to put a little text tag inside the inside this so that we know which color index we've got currently selected. So we'll accept this, save it. and I'm not seeing it. CP swatch index D. Oh, jeepers. What's it doing way up there? 8D. Color picker. All right. For some silly reason, the span we added to the CP selected swatch div is rendering up beside the working canvas. Any clue why? Picker content. Span class. I bet it's because the position here is absolute. And the selected swatch has a different positioning directive. So let's take a look at the selected swatch. Here we go. Let's take a look at one of these guys. So CP color swatch, position is relative. CSS scoping issue. I don't think it's a scoping issue. I noticed that the style we're using for the CP swatch index has position absolute, which doesn't work unless its parent element has a specific positioning attribute. Gosh, what's it called? Nope, that's a note. Where is my web inspector? Here we are. CP color swatch is using position relative. Color swatch elements are all declaring position relative. So an interesting psychological thing that I'm beginning to suspect is that working with a language model to generate code is forcing me into a much more analytical frame of mind than I am when I'm writing the code. Because if I were modifying and debugging my own code that I had generated, I don't think I'd be thinking about it as objectively and analytically as I am with someone else's code. So let's go ahead and update the CSS to give the selected swatch, relative positioning. Let's accept that. Save. And our thing, our label, is now in the right place. Great. Our index label is now appropriately placed. Awesome. Now I need to save this. Oh, subscribing to state updates, that blew stuff up. As soon as I saved the changes on the color picker view model class, it wrecked my JavaScript. So let's see what the console error is. Type error, undefined is not an object. Evaluating this.eventBus.subscribe. Okay. All right. I just saved the changes in color picker view model with the subscribe to state updates. Subscribe to state updates function. We added a few turns back. Now I'm getting console errors and the controls are all failing to render. Console log error is undefined is not an object. Evaluating this.eventBus.subscribe. Let's take a look at where we're instantiating the view models. So here's a constructor. We're creating a new image state. Here's our event bus. Here's our event handlers. Subscribe to palette events. Initialize editor. Image editor view. Okay. We need to import the editor events. Okay. Let's do that. I think that's only part of the problem. The Discord Windows app is bugging out. That's a bummer. Probably means the Mac app is also going to be bugging out because I believe Discord is just a wrapper around a browser object. All right, let's accept that. We're still having trouble. That's part of the problem. Another part of the problem is that our event bus isn't being provided to the color picker view model in its constructor. This component is set up by the image editor view. and view model. And go to the definition here. I just want to go to the file. Palette helper, preview canvas, working canvas, available scales, canvas dimensions, color picker VM, and is not being passed into the color picker VM in the image editor VM's constructor. I'll fix that in a sec. Right now, don't write any code for me. Pull that up here, drop that there. Constructor image state. Okay. Add it after you've confirmed the event bus. Also see that the image editor's VM constructor isn't accepting the event bus. It's a parameter. I'll fix that too. Now, in order to do that, I want to crib from the palette editor view model. Excuse me. So what I'm going to do is I'm going to grab this fragment from the JS docs. Excuse me, in the palette editor view model. Let's come out here, paste that, get rid of the extra spaces, event bus. Okay. And we're going to pass the event bus into our color picker. Now, I want to go into the color picker view model. I can close this. You can go back to sleep. And here we go. All right, good. So now we're subscribing to state updates. Let's see if it's actually doing stuff. So I'm going to select 8. Now I'm going to edit 8. Beautiful. And you can see that when I edited and committed the change to palette index 8 over here in the editor, it updated. Let's make this an ugly color. See, there we go. We see that the swatch in the color picker changed, and it changed because it's currently the selected color. So good stuff. And of course, you can flip back, and I'm going to revert this to what it was. 0, 255, 255. We're back to that cyan color. Okay, groovy. And our scale factor for the working palette, that is handling its stuff just fine. All right. Changes are in place, and it's all working nicely now. When I edit a color definition, the swatch in the picker updates when I want it to, if I have a color selected and update its definition, both the swatch and color in the selected element update correctly. Question: do we already have a current color property on our image state? I feel like we're going to need that when we start the paint methods on the working canvas in a minute here. I'm really pleased with the way this is all structured. Color picker view model, selected color index, tracking the selected color, no direct current color property on image state. Yes, it is part of the overall application state. Export class image state. And we want to apply this to the image state file. Off it goes. Accept. Save. All right, create new, blah, blah, blah. Untitled, palette pixel map. Creates a new blank image state. Okay. Sets the current color. All right. Current color index instead of its own selected color. Rather than updating the state directly inside the color picker, we best use events to remain consistent with our UI architecture decisions. Okay, image state now has a set current color. Groovy. So we got to add to the editor events. Accepted, but what I want to do is I want to rename this. Rename the symbol to current color changed. And change this to current color changed. Save that. Now come out to the color picker view model. Let's just pop that. Let it make its changes here. There we go. Index equals this dot selected. Color index, then return false. And not color selected. I have to come back over here and grab this. Update that because I did change the name of the event constant between it figuring things out. And subscribe to palette events. It needs to add the, excuse me, the new event. Here we go. We'll accept that. Subscribe to palette events. This is not color selected. It's current color changed. Save that. And instead of this being in palette events, I'm going to copy. Actually, I'm going to cut and add subscribe to color picker events. Paste. Add the JS doc. Subscribe to color picker. Subscribe to color events from the color picker component. Save it. And I got to spin up here this dot subscribe to color picker events. Save. All right. Now I've got my web inspector up. Let's see if I get console logs for these events. And I do. Good, good, good. We can see as I click around in the color picker. I'll shrink this down a little more. That I'm getting all of this stuff. Good deal. Publishing events, state updated. Okay. Now, I'm going to take a look at the editor events for state updated. All right, raised by pixel editor after state change. Type palette, action color changed. Okay. Type color selection changed. Now, in the color picker view model, in its subscribe to state updates, I want to make sure we're filtering those events. Palette and update action color changed. Handling state updated, update. Okay, good. We are doing event filtering here so that we're not reacting to every single event that comes in, but we can add code to handle any of the types of state update events that we might see. All right, and out here on index, we've got that, subscribe to color picker events. All right. Time to start painting on the working canvas. I think we have a view model for those. Let me confirm that. Okay, so there's our lib. We've got working canvas view model. Beautiful. There's nothing in the working canvas view. Our working canvas view model is here, and it's just dealing with the actual canvas. All right. Painting, trigger repaints of both working and preview canvases. Yes, I saw that I have an empty working canvas view file. I don't think we need it because our view, in this case, is a canvas that we've already added to the DOM. Let me delete that before we proceed so that neither of us gets confused. So working canvas, it's empty. Let's get rid of it. Okay, do I have a preview canvas view? I do, it's also empty. Let's get rid of it. Move to trash. Save. And back to Copilot. Since we're directly manipulating the canvas through the working canvas view model, we don't need a separate view class. The canvas element is already being managed by the image editor view. We should add methods to the working canvas view model to convert mouse coordinates to pixel coordinates, set pixels at the correct scale, handle both single pixel and drag operations. Let's do it. Now we can close out of a bunch of those files. Probably still need the image editor view model because we might have to do some event wire up in here. And index.js is absolutely going to need some of those. Now, as soon as it's done typing here, let's add. Here's our working canvas view model. These are all local events. Accept, or local methods. Add the necessary important event definitions. Here's that. New event for pixels changed. Accept. Save. Now let's review what it did on this working canvas view model before I save here. All right. Screen to pixel chords. All right. Set pixel. Editor events state updated. Okay. Yeah, and down here it says, would you like me to show how to set up the mouse event handlers next? I was looking for the mouse event handlers in there. So let's see. before we do that, should we be using screen coordinates, or should we be capturing mouse movement within the canvas and working with the coordinates within that element itself instead? Or perhaps my confusion is just on the naming. More precise, avoids offset issues. Okay, canvas to pixel chords. Yep, okay. Update. Accept scale, set pixel, image state pixel map pixels, image state dot current color index. Okay, good. In the set pixels method, I see we're setting the pixel to the numeric value of the selected color index. I'd envisioned storing those as hex digits just to save bytes. But if that's going to create significant performance issues because we have to convert back and forth between decimal and hex, then we can populate the pixel map dot pixels array with decimal values. What do you think? I'm going to call my breakpoint for the day being able to select a color and draw on the canvas, the working canvas, and have that change reflect in my preview canvas. That's what I'm going to call my stopping point for this stream. All right, using decimal values is definitely better than hex strings. Okay. Okay, so decimal it is. Direct array access and comparison. We have to do string conversion back and forth. Okay. Flood fill, copy paste. Only need hex conversion for display. Can use two strings, 16 uppercase. Keep internal representation numeric. Okay. No need for a perf test based on your explanation. Decimal values are clearly the way to go. Save that. And now we're going to add mouse event handling to the working canvas view model. So it looks like we're going to be adding to the constructor a this.isDrawing flag. We're going to bind mouse events to the canvas, param number, scale, current zoom level, mouse down, mouse move, mouse up, mouse leave. Okay. Existing methods. Using offset XY for canvas relative coordinates, tracks drawing state for drag ops, handles mouse leave to prevent stuck drawing state, canvas to pixel coordinates and set pixels, scale factor passed in for proper coordinate conversion, bind to mouse events when the canvas is initialized, passing in the current scale factor. Okay, let's do this. Accept. Okay, let's bind. Let's get everything connected within the view model to start. All right, so here's all this stuff. We got to import editor events. Let's go. It's going to add some things. Accept. Subscribe to state updates. Triggers a re-render when pixels change on pixels changed. All right. Save. Okay, that exploded. As soon as I saved those changes, that all went bye-bye. I'm not surprised. Yep, it doesn't know what the event bus is. That's okay. So here's our constructor. We're taking an image state and event bus. Probably doesn't know what the event bus is, which means we got to come out to the image editor view model. And when we're standing up our working canvas, we need to pass the event bus. And that should restore our view. Good. Let me select a color. Nothing's happening yet. Okay. Excuse me. So here's the subscribe to state updates, existing methods. Modify the set pixel method to use the event bus. Let's come in here. Added state update, pixels changed, XY color index. Okay, that's going to be spitting a lot of events. And it still doesn't seem to be doing much. All right. Let's do that connection in the image editor view. I suspect we might be going about this in a suboptimal way, but let's get it all working first, and then I'll talk through my concerns. I want to see where Copilot's going with this. I want to see what it's got in mind. Okay, image editor view, working canvas, this dot blah blah blah, doing things, render working canvas, view model palette helper, scale. Oh, neat. That's a cool idea. Update canvas dimensions, yada yada, boogity boo. Accept. Save. Okay, that broke some stuff. Ha! Working canvas setup after render, connected mouse events. Well, first off, that most recent set of changes broke both canvases. They're now both rectangles of the same size, and my color picker vanished. I want to see if there's any errors in my console. Oh yeah, working canvas dot width. Spawns a lot of blocks and deletes blocks. Okay, we're mixing canvas initialization between render and initialized components. Different selectors, working canvas versus working canvas. We're duplicating canvas setup code. Color picker initialization is only happening in initialized components. Let's fix all this. Yes, let's. Let's accept all of these changes. Save them. We're restored back to where we were. Good. Initialize components. Okay. Screen is rendering correctly again. We're missing a bind local events method on image editor view, though. Holy smokes, 75 gigs to render a cutscene? Can you shrink the size of the stage maybe? Or can you just add the blocks necessary to render what's visible? Like I'd try to constrain the size, the world size that your cutscene is being rendered within. Total in the server. Holy cow. 75 gigs of RAM? That's a big box, dude. Binds event handlers for image editor elements. Boogity boo. Let's add it. Here we go. Accept. Bind local events. Save that. Now, we just added or altered code that affects the scale of our working canvas. That's broken. And we've got all kinds of goofy stuff, but at least we're drawing on the canvas now. But we've somehow painting 4 discrete pixels as we go. All right. Progress. We're moving in sort of the right direction. Handle the scale radio buttons and any other UI interactions. Here's the addition. Okay. Okay. With that change, the scale button now scales the pixel data within the already rendered and sized canvas. Working canvas. We need the scale controls. Scale control. To resize the working canvas itself and then repaint the pixel data onto that canvas where each element in the pixel map is a scale factor by scale factor square at the appropriate position. There is another issue, but that's in the either the set pixel or put image data methods. Let's fix these one at a time, starting with the scaling controls. Both the canvas size and the pixel rendering when the scale changes. Okay. 10. Now, in this parse in target value, base of the number in string. Okay. Okay, so that just says parse to a base 10 integer. I haven't checked the link yet. I don't even have Discord open right now, but I'll take a look after I finish this stream session. I do want to get some things working before I call it a finished stream here. All right, so we're going to edit the scale handler. Let's accept. Okay, so we've got our new scale. The view model, we set the current scale. Working canvas, working canvas. We set the width and height, and then we tell it to re-render with our working canvas. Cool. Save that. Bring this back on screen. Now, I still expect to get a rake effect as we draw on the canvas, or perhaps not. Scale this up to 8. Nope, we still didn't update the size. So we're at scale 5 right now. And now we're starting to get multiple, but we're offset. Okay. Working canvas.height. Is it selecting the correct element? Let's see. Let's come up to render. So yeah, it is picking the right one. Now down here in bind local events, okay. Sure the image editor view model correctly calculates scale dimensions. So let's come in here, up in the view model. Intel Core i9. Wow, those are some hefty processors. All right, and that blew stuff up. Attempted to assign a read-only property. Okay, with the change to image editor view model, I'm getting attempted to assign to read-only property in my console. And this is the part where I start going back and forth with the LLM, basically coaxing it in the direction that I need it to go. So we have conflict between the getter properties and direct assignments. Let's fix it. Accept. Save. Okay, that's back. Okay. Okay. That fixed the DOM crash. It also fixed the working scaling for the working canvas. I did notice, however, when I was testing this stuff, that some peculiar things were happening when we change the scale after drawing on the canvas and then continuing to draw after the scale changed. Let me reproduce and I'll describe it. So this is where I take off my developer and architect hat, or at least shift them to the side, and I put on my QA hat. So I'm going to full refresh, get the state just completely brand new. I'm going to select color 1, and I'm going to draw a line on the canvas. There we go. Just a vertical line. Let's scale up to 8x. Boop. Now, if we've still got the bug that I observed, when I click and drag on the canvas now, it's going to drag 2. And sure enough, it does. And the first one is offset from the second one. And it looks like the offset is continuing to... No, maybe not. Hey, how's it going, Aaron? Okay. So let's reload again. I can draw once. I'm going to change my scale once. And now I've got double the cursor activity with an offset. Change it again. Do I get 3? I sure do. Let's change it again. Okay. Potential issues to watch for when testing scale changes. Mouse coordinate translation after scale change. Event handler rebinding with new scale. Pixel alignment at different scales. Drawing state persistence during scale changes. Looks like when we change the scale, we're adding an additional set of event handlers to the canvas, to the working canvas view model, and each new event handler is offset by some amount. I can't tell for sure, but I bet the offsets are based on the new scale factor. Oh yeah, Aaron, what kind of mobile optimization stuff are you working on? Stack of handlers, each using different scale factors for coordinate translation. Yep, that's pretty much what I guessed we had. So let's pop open the working canvas view model and apply this change. Excuse me. Accept. Save. Let's take another look at thatDeveloperDad's amazing pixel art creator. Refresh the screen. Got to fix the bug where when it initializes, it doesn't have any selected color. I think I'll just have it pick whatever's at index 1. And there's that. Here's that. Let's change our scale to 8. I have no offsets. Beautiful. Okay. That fixed the issue. Nice. Last thing I want to do. And before I get into that, I'm going to take a 2-second be right, or not a 2-second, but like about a minute be right back. And then I want to selectively raise the pixel array or the pixel map changed event out to the rest of the application when certain things happen on the working canvas. But I got to have a chat with Claude before we start that. So I'm going to be right back. And when I come back, we'll start doing that. Okay, sorry about that. Let's bring the main screen back online. So we remove the existing mouse handlers, we rebind them, all of that stuff. So this is the working canvas event model, or view model rather. And Claude has thoughtfully asked me, would I like to move on to handling the preview canvas updates when pixels change? Yes, I would. Once that's connected, I think we can call this a successful working stream. Then you and I are going to keep refining the drawing stuff. We're getting closer and closer, folks. Like when I really move the mouse quickly, I don't like the way that it's not capturing all of the things. And if I accidentally bump the mouse out of the area while the mouse button's down and bring it back in, we lose it. But these are bugs that we can troubleshoot later. I just want to get the basic functionality mostly working, and then Claude and I will do all of the debugging and refinement and stuff like that after the fact. Okay, so in the preview canvas view model, let's make sure it's set up to handle pixel changes. Right now, we just have our render method. It doesn't know to subscribe to anything, so we'll accept, save. That exploded because preview canvas doesn't have an event bus. Easily fixed. Here's our constructor. We're going to come down to initialize components out in the image editor view. So come down here, initialize canvases. Go to definition, initialize canvases. Here's our preview canvas VM. .render. Preview canvas. It gets rendered within the hashtag preview canvas, or it is the that .render. I need to go back up to wherever those things are being created. Update canvas dimensions, color picker view. Oh, that's happening in the image editor view model. So we're going to come up here, and pass the event bus into the preview canvas view model. Now it's happy. And I believe this is on what, the preview canvas view or view model? View model. So we'll come back here. And I believe we've applied all of those changes. Now I have to update the image editor view to go here to connect everything. And Claude and I are going to have to do some cleanup inside this image editor view because we're doing a lot of things that are unrelated to initializing components or should be split out into discrete things. Set up preview canvas pixel change callback. Preview canvas, view model palette helper. I think it's trying to do direct stuff here. Not sure I like that. Okay, render those things. Live updates of both canvases when pixels change. Preview canvas is always at 1:1. Working canvas at user selected scale. shared state through image state. Let me save all, pick a color. Let's go up to 8x. And you can see, if you look carefully, that my preview canvas is updating as I add things. Pretty sweet. So 8x, let's say I need bricks. Here we go. We'll just make them kind of uneven, kind of goofy looking. We got to fill in some of these blank lines. There's some there. We'll add another line around here. Let's just fill these guys in, shall we? And we'll do that, and we'll do this. One more row. One more course of stones. And we'll just add that. There we go. Thicken this line up a little bit. Happy little stone wall. Do 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 do. All right, and we are able to put some graffiti on there. We've got a happy little stone wall. Not bad. I'm already thinking of affordances and ways that I can extend this a little bit. But I'm going to force myself to not add a bunch of features until I've got these ones working the way I want them to. Let's take it down to a 5x. Thing of beauty. Let's give our happy face some red hair. Spiky red hair. We'll give him red eyes. And a big, crazy smile. And we'll just draw that circle again. So yeah, this is fun. This is an awful lot of fun. All right. I think we've had ourselves a successful streaming session. Because now we're capturing the mouse events on the canvas. We're able to select colors to our heart's content. Let's give them little blue irises. There we go. Can't really see it in there, but they're there. If we blow it up real big, we can see. There we go. All right. And we can zoom all the way out to native resolution, 4x, 5x, 8x. We can go as high as 8x with this one because this is a 64 by 64 and our working canvas is constrained to a maximum size of 512 pixels. I wonder what happens if I grab this cyan and edit it. 128 by 128. Okay, it did not update the pixel map. So that's fine. That's okay. I think we're in a good spot. This is great. We have a couple minor issues and a couple probably harder to fix issues to handle, but it's time to conclude this stream session. I'll detail those issues in a few minutes. All right, friends, we've got a pretty successful little experiment here. Under my direction, Claude 3.5 Sonnet and I were able to build a very simple paint program that runs in a browser. It's pretty sweet. This is really, really, really fun. And there's some things I want to do to extend this to give it a bit more utility. We still need to work in the image management stuff, which means being able to save these things as PNGs or JPEGs, or even the JSON data that makes up the image state itself. But we'll get into that stuff tomorrow. And I think I'm going to spend the rest of the working day when I get back to it, resolving the minor issues that I've seen and adding some new capabilities on the actual canvas itself. So thanks for hanging out. I hope you learned a few things about working with AI or manipulating HTML5 canvases with JavaScript and stuff like that. And until next time, I wish you happy coding and good day. Bye now.